So to finish up this block of videos on turning our NPC movement script into our Slender script, let's just add in our teleport functionality. Now at this time, I'm pretty much going to draw exactly from what I wrote before. Because it's working perfectly. Or at least we can use it as a point of reference to start with. So here's our function teleport enemy. Let's just expand that out a bit. Okay. So here we are. We invoke our teleport starting at 60 seconds, and every 20 seconds after that we're going to call teleport enemy. Now the first thing I did, check if off screen. Now I haven't included the two dot checks in this second guide. All I've done is the one for visible. So we do have that. We can check if we are visible by calling this function, and then after that function is called, it's going to assign a value to this variable. So we check if visible is true or false. Now we don't want to teleport while we're visible, so we can just put a conditional in straight away for that. So if we are not visible, then we can start thinking about teleporting. So check the distance. Okay, now this is kind of important because, as I mentioned in the old guide, if he's quite close to us and then we go and induce a teleport, we could move him further away. And that's going to make things a little bit boring. So let's just do that too. Now, this is how we've been checking the distance up till now. We're using a square magnitude. Now what can we compare this against? What did I compare it against before? Check distance. Let's go to that function. Check distance, square follow distance. What's our square follow distance? Let's go and check that out. Our square follow distance, I'm sure, is the same as what I've called max range in our new script. So let's just employ that variable. So let's go back to our start function. So our maximum range squared, we're going to be comparing that. So we're going to check if visible, and then we're going to check our distance. So then we're going to ask if our square distance is greater than our maximum range square distance. So he's definitely far off into the distance. He's nowhere close to us. So if he's way out there, then we can start looking for options of places to teleport to. So again, what did I do previously? Okay, teleport distance, I set that a hard value, and then I brought in the left and right. That's correct, and then we do a raycast. Okay, so let's explain what's going on here. First of all, let's set up the raycast part. So if we have found a condition where we're not visible and we're out of range, we can certainly teleport. So let's do a raycast. So let's set our variable for our hit, which will store our raycast hit information, and let's do the raycast. If physics dot raycast now we need to find a place to raycast, and that's all the random stuff. So let's set up our teleport distance again. So what kind of range are we going to teleport to? Let's just take our maximum range. Let's just add 5 units to it. Okay, that's good enough. That's whatever we've set as our maximum, what we said we cannot see him off in the distance. Let's just add 5 to it just in case. And alternatively, we could be casting him 5 units away from us. So let's just check there. Okay, so it's greater than our maximum squared range, plus 5. Then we're going to set our distance to that distance. What happens next? I'll get into that part in a minute. So we're going to get a vector 3. So let's create var terrain position check. We're going to check a position on our terrain. This is going to be a vector 3. And this is going to equal my transform position plus, and I'm just going to hard code this to a position next to us. So our transform position, and we're going to add to our position our transform right. Now that's only going to bring 1 unit next to us, so that's why we have a teleport distance. I'll add that, and I see where I've made the mistake. We want to teleport close to the target, so it's not the transform, it's the target position. Alright, so we're going to pick a new position that is our target, but not right on top of him. Let's go to the target's right at a distance of this distance. Okay, so that's just picking a point that's directly right of the target at that distance. That's range squares. Look, I'm even. Okay, so square is going to put him way out there. So it's maximum range. Okay, I hope you just followed all that. So for square magnitudes, we check against our magnitude. A square magnitude, 5 times 5 is 25. Okay, if he's outside that zone, that's a squared value. This is the value before it's squared. So this is a real distance, and then we find a vector 3 position that is to that right. Now we're going to be raycasting from way up in the sky. We don't want to check from the ground level because we could be starting from the terrain. So let's set our y to a hard-coded value of 1000. Nice and high up in the air. Actually, I'm even going to one step further. I did this in the comments with someone that was having problems with this. So what we're going to do is we're going to do an infinite raycast. We're just going to raycast for infinity. So let's even set that. I can't see anybody having the height of the terrain greater than 5000. So there we go. So we now have got a position that we're going to raycast from. So let's raycast from that position, which is all the way up in the sky. Because it's all the way up, we're going to check directly down. So we are going to use the vector 3 up. But we don't want to go up, we want to check down. Okay, and from that raycast we want to gather hit information. And what is the distance of that raycast? Well, again, we could put 5000. What if someone has their terrain set really low? This is where we're just going to cast an infinite ray. So math f dot infinity. So we pick a position that is to the right of the target and this far away from the right of the target. We're going to set that position way up in the air, and then from that position way up above the ground, we're going to cast a ray all the way down into infinity, or until it hits something. And then we're going to check what we did hit after that. If the hit and the collider that it hit, and the game object attached to that collider, and its name is equal to terrain. Now again, this could quite easily break in case we raycast on top of a tree, but for raycasting on top of any other colliders you set up, like just say you have a pool of water and you have set its collider to be water, or you have buildings, objects, other things like that, other models that are not named terrain, then this is going to be fine. Anyway, let's move on. Okay, if our hit collider game object name is terrain, that means we've found a place on the map. Okay, what have I done? Physics raycast. I've obviously forgotten one of my brackets. Position, direction, hit information, distance. What have I done there? Alright, if all else fails, check the API. Brain's starting to dissolve. Okay, origin, direction, hit info, distance. What's going wrong with my Raycast declaration? Hit. What are the parameters that the error say it doesn't like? The engine for the argument list. It's saying I've closed it even before I've opened it. Now that I do not understand. Let's just even cross-reference that to another raycast we've done previously. That just does not make sense to me. Here's another raycast. Let's just copy that. I'm not going to use it. I'm going to use it as a reference. Where are we? Teleporting. Teleporting. Okay, here's our example raycast we've used before. Physics raycast, bracket, position, direction, hit information, distance. Okay, something's fallen apart there. What's going on? Terrain position check is a vector 3. Okay, I don't know what's going on here, but it doesn't like one of my brackets. So let's fix that up. Alright. There we go. Can't explain that. I honestly can't explain it. But as you see, as a programmer, you always have to think around things. And for me, that was just simply changing the format of what I typed. I didn't like it for some reason, but there we go. It's all back in action. If hit collider game is terrain. Okay, so we can safely assume that we found a position on the terrain that is safe to teleport to. So, we'll cross-reference. Okay, yep, of course. Alright, so we're going to set our transform position. We're going to set it to the hit point. And again, go back to the Raycast video to find out what this information is. But we're going to add to it. Because of that collider penetrating terrain issue, we don't want to teleport somewhere and then have him fall through the floor. So we're just going to add a little bit onto the Y. Okay, just a hard-coded value. And I usually use 0.25. That usually gives you a good enough clearance off the ground. Okay, our transform position is now our hit point that we just found, plus a little bit on the Y. Now what was that second line there? I just looked at the player. That's all taken care of in the movement anyway, so I'm not even going to worry about implementing that. So just to recap everything, we just built the teleport enemy function. We're going to check if we're visible. If we're not visible, let's do some more checks. So we check our distance. If we're further away than what we're calling our maximum range, then we're going to start looking at casting a ray to see if we can move. So we assign a position to raycast from. We set it way up in the sky. We do a raycast from that position, straight down. Then we check our raycast if it hit the terrain. If it hit the terrain, it's not hitting the player, it's not hitting a building. So then we can assign that position as our new teleported position. So we're teleporting, so we just immediately assign that. So our transform position will then become our hit point plus a little bit on the Y, so we don't fall through the floor. Alright, let's check that out. Now I have set this invoke to 60 seconds, but we want to see it happening kind of straight away. So this is what I normally do as well. So that's the bit I want to keep. So I'm just going to leave that at the back of the comment so I don't lose that. And let's make it really quick. So it's going to start in 1 second, and then let's just say 4 seconds. Every 4 seconds he's going to check for a teleport. We should see some instant action there. So let that compile. Now that silly error for no reason has gone away. Let's just keep an eye on our transform. Now our player's not moving, alright, so let's leave that in the center. So he's always going to teleport around unless he gets within that distance. There we go. Okay, he's come within that minimum square distance because you see he's line casting. Let's drag him away, see if we can get it to happen again. There we go. Sometime in 4 seconds he's teleported. Drag him away again. There we go, not even 4 seconds.